Today, we're going to be talking about looking at a graph and using the vertical line test to identify if a certain graph is a function or not. And then we're going to talk about what a function actually looks like and compare it to what we've been working with already. So to start off with, looking at 9 graphs. Some of these you already have in your notes, but I want to give you a lot more examples. So what the vertical line test is, if we look at a graph and we take a vertical line and we can run a vertical line through the entire graph and it only hits in one spot, as it does here, that makes it a function. So if I'm coming down here like right there, it's only crossing the graph at that spot right there. As I move a little to the far right, maybe it's only hitting it right there. And then it's only hitting it right there, and it keeps going out wider and wider. There is not one vertical line that will cross this graph, and when it does, hits it twice. So this is a function. Looking at number 2, this kind of like sideways, this kind of like C with arrows going out of it. I can take a vertical line, and this is multiple points. There's my vertical line right there in green. It's hitting this graph in 2 spots. Because it's hitting it in more than one, meaning 2, 3, 4, as many as possible, this makes it not a function. Oops. So look at number 3. This figure that looks like an M, which is a quartic function, something to x to the 4th, which we'll talk about in Algebra 2 or pre-calculus. This graph, can you find a line, a vertical line that goes through and hits the graph more than once? No, you cannot. So this is a function. Here's number 4. It's a circle. I could draw a vertical line right there, for instance. It's hitting it in those 2 spots, therefore not a function. This one's a little tricky. You have a couple horizontal lines. Now, is this a function? If I vertical line, all right, well, if I draw a vertical line right here, that's a closed circle, that's an open circle. This open circle says it's not part of that line, so that's still good. It's still hitting it one time. We get here. It's hitting it here, but not here on this open circle. If I come here, it's hitting it here on this closed circle, but not the open circle. So therefore, this is a function. Now, how we can change this? Think about how we can change this to not a function. We can simply maybe close this in. By adding that as a closed circle, this changes it to not a function. Because now we have 2 dots on that vertical line. What about this vertical line right here, number 6? That should be an easy one. Not a function. This graph over here, number 7. A bunch of points. But, vertical line through 1, to that one, only once, only once, only once, only once. All those vertical lines only go through one time, therefore, function. Compare it with number 8. There's my first vertical line. It's going through 2 points, not a function. And then we have this kind of Z-looking figure. Here's a vertical line. It's actually going through 3 times. Also, not a function. So if you understand the vertical line test, identifying what's a function, what's not a function, makes it very easy. And thinking back to when we're mapping and making XY charts or looking at ordered pairs, something like this, these points might be like 3, 4, 3, 2, and then 3, -1. The x's repeat. That's why we're looking for vertical lines. Every vertical line, the x values will be identical. The second part of this lesson, we're going to be evaluating functions. Now, it's nothing new. It's just going to look a little bit different. A little bit more official, kind of fancier. So I think the problem we used in your notes, let's see, was y equals 5x plus 3. Now, in function form, the only thing that changes is we have this kind of notation. F of x is substituted for y. Y is the same thing as f of x. This is more like a mathematical symbol. This is more algebra. This is just more a lot fancier. So when we're looking to evaluate, I want you to evaluate this function with a domain. What numbers did I pick? -4, -1, 0, and 3. And I want you to find what the range is. Remember, your domain values are your x values. So these are your x values. We want to find what our range is, which is our y values. Now, again, this is an x value. Where do you think the -4 goes in? F of x equals 5x plus 3. It goes in for the x value. So we go f of -4 equals 5 times -4 plus 3. I'll multiply it out and then add. 5 times -4 is -20. -20 plus 3 is -17. So the first y value, part of our range, is -17. We now want to substitute -1. So again, we put -1 in wherever the x values are. 5 times -1 plus 3. 5 times -1 is -5. -5 plus 3 is -2. That's our second value. The third value you have to use is 0. Again, I love the number 0. Anything times 0 is 0, so that's totally canceled out. We're left with 3. And then finally, we're plugging in 3. F of 3 equals 5 times 3 plus 3. We end up with 15 here. 15 plus 3 is 18. So, to get our range here, we substitute in our domain values, our inputs, and we get our outputs. -17, -2, 3, and 18. You can do this with any function, whether it's an x squared or a combination of anything that goes on. You just substitute these values, the domains, in for the x's wherever they appear. See you next time.